Hey guys, and welcome to this session on data visuals in Seaborn. And today I want to take a look at the linear model plot, or as Seaborn calls it, the LM plot. And effectively what this is a cross between a regression plot and a facet grid. So first of all, a facet grid is basically something like this. It's where we can do a plot effectively across several subplots, which is quite useful. So we can plot multiple variables on each and then kind of get like a big picture as to how do all of these relationships look like from a higher level, which is pretty cool. And of course, it's going to be using a reg plot, which is a regression plot. So if I just head over to this for a second, it's basically plotting a linear regression model to our data, which is good. So it kind of gives you like a nice line of best fit across the middle. So if you want to try and plot some data and then use a regression line to make predictions about possible future data points, then you can go ahead and do that. So if I just quickly scroll down, I'll show you what a couple of these graphs look like. We've got one here. So this is actually using the penguins dataset from Seaborn. So we have bill length on the X, bill depth on the Y here, so you can see our different scatter points. If I scroll down a tad more as well, we can see that in previous videos you may have seen this. You can pass in a hue parameter, and this will effectively plot the X and Y, but there may be groups in those X and Y variables. So in this case, they've done bill length and bill depth again, but there's actually 3 different species within the data set. So then it's gone ahead and done 3 separate plots on the single plot, which is cool. Now, where the facet grid comes in, if I try and find one, probably this one here is good enough. What you can do is you can pass in a column here, and this will effectively create an individual plot for each distinct thing in this column. So they've got species in this case, and that's represented by the blue, orange, and green bits here. But in this sex column, there's 2 different sexes in this data set, so then it's done 1 for each, which is quite nice. So if you want to kind of compare what's this relationship look like for each species, and then split it apart by this column, then you can go ahead and do that. And you can see here as well, it's done it across this one where it's done 1, 2, 3, 4, 5, 6 different plots, which is pretty cool. So back into VS Code, we're going to take a look at our student performance dataset. It's a really kind of nice, crisp, clean one to work with. I'll make sure that's linked in the description as well. So I've just got this set up here, which is good to go. Just to show you the dataset, in case you've not seen it before. It's basically got 1,000 data points. It is a fictional dataset, so it's been randomly generated. And there's kind of like some inherent biases for it, which is pretty good, and we can pick those up. And then for the rest of the columns here, so say if I just take one, for example, we have this test preparation course. So the idea for this is the ones who have completed it generally have higher scores, so we should see that when we plot the data. It's the same for like lunch as well. So it kind of argues that those on a free/reduced lunch generally have lesser scores, so we can see if that's true when we plot the data. In terms of my setup, I have a virtual environment activated, and I've just gone ahead and installed these. So I've done pip install pandas, Seaborn, and matplotlib, and I'll show you my setup here real quick. So I'm working in this file, and I've kind of got a data folder and an images folder. So I've gone ahead and just done this path relative to me, and then I've got this save path for later. So this is going to be kind of for my plots here. Just rather than typing this out every time, I'm just going to go ahead and reference this variable. And we've gone ahead and imported our data set. Just what you can do, if I want to kind of just check it works, if you go ahead and run df.info, we can go ahead and run this, and we should see a little summary of our data. And there we go. All looks good. So let's get this cleared up, and we'll go ahead and try a couple of different plots. So we'll start off pretty simple here. We'll do a quick linear model plot, and we'll compare some of these scores here, and then we'll get a bit more complex, and we'll start to bring in some multi-plots. So we'll start to plot these, and we'll try and bring in as much of these as possible. So the first thing I want to show is just our basic X and Y plots here, and then as we progress through the video, we'll gradually introduce more of these features, but hopefully by the end of the demonstration, you'll have a good idea of how to produce these linear model plots. So as you can see, I've already got my data set read in here, and I'm simply going to come along and do sns.lmplot. We can see we get our options here. So the first thing it wants is my data. That's here. So there we go. I can just do data is equal to df, and then I want to specify x is equal to some column, and then y is equal to some column here. So what I can actually go ahead and do, just to save myself a bit of time, is just quickly grab these. So I can grab math score, and I think we'll do math versus, let's do math versus writing. I mean, you could do any of these numerical ones really, just to get the gist of how it's working. Okay. Now, because I've got my save path already up here, all I can do is then just do plt.savefig and then simply pass in my save path. So this here is going to produce the figure. This here is I'm going to take that figure and then save it to this path here. So I can go ahead and hit run. It should take just a second because it's a fairly sizable data set, I suppose. And there we go. So this data set, I would argue, is very linear. So, you could argue that as the math score increases, so does the writing score, almost on like you could sort of say almost like a one-to-one basis. So, yeah, here we go. So if I kind of zoom in a bit in blue here, there is my regression line. So you can see this is a very solid kind of positive linear correlation. And then my line of best fit, or my regression line, is obviously reflecting this here. Suppose you had a more sparsely populated data set. This regression line could then be used to make future predictions. So say, for example, we had none of this data here, and you said, okay, someone's got a 20 in math. What are they going to get in writing? You could simply head north from your 20 until you hit your regression line, and then go to the side, and you can say, okay, it's going to be around here for my writing score. This, of course, is a very kind of clean, well-done data set. So, of course, my regression line is really straightforward and simple in this case. Now let's introduce a hue into play. So if I head back to my data set here, I can choose any of these guys. So maybe we'll do lunch for this one. And all we'll do is we'll say hue is equal to, and pass it lunch here. So this will now redraw the graph, but because I think lunch only has two options yet, it's got free, reduced, or standard. So what it will now do to this plot, rather than saying, show me the entire cohort of students, it's going to put these into two colors where each color reflects what kind of lunch a student has. We should see those regression lines as well. Hit run again. This should look different now, and it does. So let's go ahead and take a look. We can see our regression line is very similar, so there's not a huge difference between them. You can see in general that it looks like our free/reduced tend to be on the lower end here. And of course, loads of our blue dots tend to be appearing kind of on the upper right-hand side, which is fairly interesting. So yeah, I guess that's showing that in this data set, there is some kind of tangible difference between those who have the standard and the free reduced lunch. And you would do exactly the same. So of course, if you wanted to say, okay, someone's on a free/reduced lunch, they have a score of X, whatever, you would simply go to the orange line in this case. You could then use that to then make your prediction. Now at the moment, because we haven't done a col or row parameter passed in, we're still doing this on the same plot. Now recall earlier on I said that this combines effectively a regression plot with a facet grid. When you start to bring in these column and rows here, that's when you start to kind of get the multiple subplots. So what you say, well, I'm just going to see one this time. So if I replaced hue with col, and we'll do lunch as well, and hit run again, it's going to look different again this time. And there we go. So this is just a different way of seeing it. So this is just giving you a different way of looking at it. And I think for these data sets where we have a very densely populated data set, especially where there's a fair bit of overlap of scores, I would argue that doing it this way, using the col parameter, is arguably better. You can also do, like say if I passed in hue is equal to, and let's do gender, we can actually redraw this. So we're saying for each distinct group of lunch, that is going to be its own distinct graph. But then on those graphs, then kind of, draw however many of these there are. So in this case, let's see, we've got two genders in this data set, we've got two lunches, so we should see two graphs, each with kind of two groups of plots. So we'll hit run again and just see what that's done. And yeah, we've got exactly the same there. I guess it looks like the gradient is perhaps a bit more on this side here, which is interesting. So yeah, so we can see here's our two lunch groups, so one chart for each. And then for each of those charts, we're then drawing on our distinct groups, which is quite cool. Now then, let me show you something else we could do. Suppose we then did col, so we've got col and hue sorted. Now I'm trying to best to show this without making it look kind of too crazy. Let's pick another one. So let's do this time. Let's do test preparation course. So there's only two of these that I've ever got it like as completed or none. For the parental level of education, I think there's like 5, so it would look kind of crazy. But we can do row as test preparation course, and then this enhances our graph even further. And there we go. Let's bring this down just a second. So check out that level of analysis. If I try and zoom in just a tad, so we can see for example, if I just take my bottom right graph, these are people who have done a test preparation course, so they've completed it, but they're on a free/reduced lunch. Let's try and pick which one would be the best. I imagine it'd be this one here. So once you've done the test preparation course, but they have a standard lunch. So, and it looks like here, I would argue they're a bit more concentrated on kind of the 80 to 100 mark here, and those regression lines should reflect that as well, which is pretty cool. So this is purely just by saying pass in a, zoom out a second. So this is purely just by saying pass in a column and a row, and of course this hue as well can then come in and say, now for each of those like distinct groups here, split them even further. So let's make this analysis even more, even more detailed, which is kind of cool. So for this last bit, what I want to do is show you what this share X and share Y means. So I've just removed the row parameter, and if I come back into here, you can see I've got my standard lunch and free reduced lunch, and we're still showing the two genders for each of these different plots here. Now, see how like for the X-axis, we've got 0 to 100, 0 to 100, but this one here doesn't really have anything in kind of like this 0 to 20 range. I mean, bar this one here, there's a bit of blank space, which perhaps isn't ideal, and that's because they're sharing an axis. So what we can do is we can say, actually, don't do that. So if I do share X as equal to false, rather than make the axis the same, so going from 0 to 100, it'll do them relative to what is on each of those individual graphs. So now I get, zoom in a touch, yeah, there we go. So see how the ones who have the standard lunch, because there's kind of nothing from 0 to 20, yeah, it doesn't bother showing it. It just starts at 20 and goes to 100. Whereas for our free reduced lunch, we're starting at 0 and going all the way to 100 as well. You can do it for, let's zoom out just a tad. This can be a nicer way actually. So when you're showing lots and lots of stuff like this, just stack them on top like that instead. So we'll do share X as false, and share Y can also be false as well. We will hit run again. We should see the same is true now for our Y-axis, and it is. So yeah, so we can see a slight difference here as well. So the 20, I know it's used the same numbers, but it's done them slightly differently here. So there's actually a bit more space on our standard lunch, whereas for our free/reduced, it looks a bit more tightly packed. And of course the 20 for the standard one is starting around here as well. And there we have it. So now I've shown that, I guess, the basics of the LM plot here. There is still way more attributes you can pass in, and a lot of stuff I've done in the previous video, so things like using color palettes, they apply here as well. So there's a lot more customization that Seaborn offers. Of course, I'll leave a link to this in the description as well, and I'll also leave a link to the dataset I've used for this. Cheers for watching, guys, and don't forget to check out the other videos in this data visualization series. Thanks.